This video is part 1 of the Chapter 39 video on Taylor and Maclaurin series. So we look at Theorem 236, and this is a very brief outline of Theorem 236. But we're defining our function f of x in terms of a power series on the radius of convergence. So this series doesn't necessarily converge everywhere, but where it does converge, this function will be defined in terms of this series. If you can do that, it turns out that there's a formula for the coefficients. The nth coefficient is the nth derivative of f at a divided by n factorial. This notation here, this is the nth derivative. So the 0th derivative is the function itself. And what I'm going to do for the rest of the video is to explain this formula. So we start by writing our power series out as these terms. So we have c sub 0 plus c1, x minus a, etc., etc. And now we look at what the derivative is in terms of a. So remember in the previous video we talked about when you can write a function as a power series, it looked like an infinite polynomial, so we treated it like an infinite polynomial. We differentiated it like an infinite polynomial, and we integrated it like an infinite polynomial. So that's what we do. Our function evaluated at a, all of these terms go to 0, except for the very first one. So our function evaluated at a, in other words, the 0th derivative, is c sub 0. Now what happens when we take the first derivative? When we take the first derivative, the derivative of a constant is 0. We have c sub 1. Now the rest of these terms will have 2 times c sub 2 times x minus a, but the rest of these terms all have a factor of x minus a in them. And so when we substitute a into the first derivative, we have c sub 1. What about the second derivative? Well, when you take the second derivative, this goes to 0, this goes to 0, and what is the second derivative here? It's 2 times x minus a is the first derivative, and then the second derivative is 2 times c sub 2. So the second derivative evaluated at a is simply c sub 2. The rest of these terms all have an x minus a in them, which go to 0. What about the third derivative? This goes to 0, 0, 0. This first derivative is 3 times c sub 3 times x minus a squared. The second derivative is 2 times 3 times c sub 3 times x minus a. And so when we get down to the third derivative, we have 3 factorial times c sub 3. All of these terms have an x minus a in them, and they go to 0. And the same thing is true for the fourth derivative, and in general the nth derivative. And so the nth derivative of f evaluated at a is n factorial times c sub n. So we solve for c sub n, just divide both sides by n factorial, and this is where our formula comes from. Definitions 237 and 238 are the definitions of the Taylor and Maclaurin series. So assuming your function f is infinitely differentiable, in other words, you can take derivatives of any degree, of any order. So you can take a derivative of any order, you can take all the higher order derivatives that you want. This is the Taylor series. Now, it may not converge everywhere. Again, remember what a power series does. It will converge only at a, it might converge on the entire real line, or it might converge on an interval of finite length. But this is what the Taylor series is, regardless of where it converges or doesn't converge. A Maclaurin series is a Taylor series centered at 0. So if your a is 0, then your Taylor series is a Maclaurin series. So we just have the nth derivative evaluated at 0, and then we have x minus 0 to the nth power.